Now for the most popular clustering algorithm in the world, k-means. It has a wonderfully simple loop at its heart. Just 2 steps, repeated until things settle. Let's watch it work. Here are our customers again, plotted by spend and visits. No labels, just a cloud of points. Our job is to sort them into groups where the members are similar to one another. K-means asks one thing of us up front: how many groups do we want? That number is the K. Let's choose 3. The algorithm then drops 3 markers, called centroids, at random starting spots. Think of each centroid as the current guess for the center of a group. Step 1. Assignment. Every point looks at the 3 centroids and joins whichever one is closest. Watch the colors. Each customer takes on the color of its nearest centroid. Now every point belongs to a group. Step 2. Update. Each centroid slides to the average position of all the points that just joined it, the true center of its group. Because the centroids moved, some points are now closer to a different one than before. So we simply repeat. Assign again, points rejoin their nearest centroid. Update again, the centroids recenter. Assign, update, assign, update. With every pass the groups get cleaner. Eventually nothing changes. The centroids stop moving, and no point wants to switch groups. We say the algorithm has converged. And there they are, 3 tidy clusters, discovered from nothing but the data. What is k-means actually trying to achieve as it loops? It is quietly minimizing one number, the total squared distance from every point to its own centroid. This is called the inertia. Tighter, rounder groups mean lower inertia. 2 honest warnings. First, the random starting spots matter. A bad start can give a worse answer, so k-means is usually run several times and the best kept. A smarter start called k-means++ does this for us. Second, k-means loves round, evenly sized blobs. Long, stringy, or very different sized groups can trip it up. In scikit-learn it is just a few lines. We create a k-means with n clusters set to 3, and fit it on X, no labels needed. Afterwards, .labels underscore tells us which group each point landed in, and .cluster centers gives us the final centroids. To recap, k-means clusters data by repeating 2 steps. Assign each point to the nearest centroid, then move each centroid to the mean of its points. It minimizes inertia, needs you to pick k, and prefers round groups. But that raises the obvious question: how do we choose k? That is next.